missing the target.
So it's interesting, yeah. So I must remember that because I've just started using ChatGPT 5, and it is different.
Yeah, no, it's still hallucinating at the same rate. So we've got all the old.
What did you say? Hallucinating?
Yeah, that's the big issue with large language.
What does
hallucinating?
What does
Giving you totally irrelevant data.
But that's okay. So that's interesting.
Yeah.
So we must get a category catch up. So, welcome.
Thank you.
And we're very lucky again. Another one of my podcasts where I talk to people who I find interesting. We've got Christie Meyerberg, who I have to be careful what I say is an AI specialist.
No, I would rephrase that and say computational complexity specialist.
Computational complexity specialist. Okay, no, that's good. And actually, that kind of reframing of what it is part of what we'll talk about, because I think one of the, from what I can see, one of the challenges with AI is that people don't understand it. But let's go back to the beginning a little bit, if you don't mind. Is you and I, not only are we both very good-looking, bearded, handsome guys, but you and I also share another thing, which is both having suffered brain injuries.
That's true.
But you were a bit younger when yours happened. Do you mind telling me a tiny bit about that?
Sure. I was, if my memory serves correct, I was around 5 years old.
Yeah.
And I climbed the fence because we had a nice little playground on the opposite side of the road.
Oh, yeah.
And as I was running across the road, the shift change bus from the mine was
so you got hit by a bus.
And I got hit by the bus.
And how long did you spend in hospital?
Around 6 months.
6 months.
Yeah.
Now, I only say that because, I mean, it's kind of just a coincidence that you and I discovered, but I thought it was interesting because we've talked a little bit about how brain injury can change people in different ways. Right. And so then you ended up in studying geology. Is that correct?
That is correct, yes. Started off for a very short amount of time studying veterinary, I
didn't know you were a vet.
No, I wasn't. I studied that for like 6 months, and then I changed direction and then moved into the geology, chemistry.
But you didn't end up doing geochemistry either.
No. So when my first job started, when I completed that, and then I started work in civils engineering as a geotechnical engineer.
Right. What's that got to do with computers?
At that stage, I got into computer programming, and I started to develop software that make recommendations for installing support underneath engineering structures.
So I've learned this with you, is that you say casually, I just started programming, and I go, how? Because you don't just casually start programming. So one of the things you and I, Christie and I, have talked about is about creativity. And I realised I always used to think that tech, or certainly programming, sounded very dry. But the more you and I talked about the way you create IP, is it's actually very creative because there isn't a rule book as to how you do it. So when you say I started programming, how do you start? That's like saying I started playing the piano.
So if you think, if you abstract that a little bit, what is a programmer really doing? Okay, a programmer is just taking whatever someone tells him, a problem he's got in the real world, and he translates it so that the computer understands what it is that you want to do, basically. All right.
So that's interesting. I've never heard anyone call it a translator before, explaining to a computer what the real world
and
wants of it.
That's part of, that's one of the biggest limitations of computers. Okay, that people don't really think about is that anything that you want to do on a computer, you have to be able to represent it as zeros and ones. And that's why the vast majority of problems we cannot solve on a computer.
Okay, so I was hoping to not
but
not have people get too down about the exciting things about AI, but I kind of thought that probably for all the things we might talk about AI, actually the most current challenge, which is why I really wanted to talk to you about it, is actually that AI may not deliver what we thought it might do. Can you explain that to us?
Let's then take a step back.
Sorry,
because for a while, AI did perform exactly the way we sort of predicted. So what's the biggest difference between artificial intelligence and the most abundant examples we've got today is machine learning of that, and me sitting there and programming. Okay, for me to create a program, I need to physically code all the rules
Okay.
and all the things I want that computer to do.
Okay.
So the promise of AI and machine learning is that you don't need to sit there and give it all the rules. It can actually look at data,
Hence the word learning.
hence the word learning, and
Okay.
it can make inferences from the data that it sees.
Okay.
Okay. So, and then way back in the 1940s, we started with linear perceptrons, which is the most basic neural nets. They already had that discovered in the 1940s. But it's computational complexity or computing power that actually prevented us from,
Right.
driving it forward, and
Okay.
the lack of data.
And these are kind of diodes open and shut kind of
That's
things.
right,
Okay.
yes.
Okay.
But then sort of, we started to generate huge amounts of data, and we had Moore's law, which says that our computational power sort of can double,
Yes.
every 18 months or something
And
like
up till
that.
quite recently, we were doing that.
Yeah, absolutely. That actually held very nicely until sort of 2005. And then we started to run into some physical limitations, and that's scaling.
Okay.
So we had to change the architecture of our CPUs, those kind of things.
Right, because one of the things that we talked, you and I talked about quite a lot is how come you and I are so much faster than computers
For some things.
for some things. Like I used to say to Christie, why can't AI drive for me? And you said,
Well, simply because of the sheer amount of variables actually that's out there that it
yes,
needs to
but
monitor.
you and I deal with that. How do you and I deal with? As you said, I mean, more than 8 or 9 variables makes things almost unmanageable, and yet you and I do that.
Yeah, so in our brains, we don't optimize. Okay, because if we
How
optimize...
dare you? What do you mean I don't optimize?
That's right.
Tell me what
If
you
you
mean by that.
had to optimize every decision that you make, you'll grind to a halt. You simply won't be able to do anything.
So are you saying that I'm guessing?
Well, call it rules of thumb. You've got heuristics, okay? So your brain, over the years, you learn things, okay? You know what start to work. You know what what doesn't. You sort of find shortcuts. And that's sort of the stage 1 that I talk about, cognition in your brain.
Right.
So you've got these very fast and efficient capability to process and recognize patterns. That's coming from the Stone Ages.
Because I've heard Anil Seth call us a prediction machine, in that he says that we actually know what a situation is going to be like, and then we just check for differences from what we anticipated.
Yeah, we in the science field in general, we've gone down a certain route, and then we discover no, it wasn't the right way, and we'll go a different route. Like, for example, our when it comes to genetics and our genome, for a long time we thought genes were some kind of protein, and then we followed that for 20-25 years, and then we discovered no, it's actually not protein, it's more like an acid-based okay.
And also the one that I was actually explaining to some today is that being genetically identical is not the same as being identical.
That's right.
People are very disappointed with their cloned dog doesn't look like their current dog, even though they're genetically identical, because expression is a thing.
That's right.
And as you said, and then genomes become a bit disappointing and they don't open doors. So you're saying that the AI is...
No, so let's then, okay, so then for a long time, when AI finally took off, because computational power sort of, we have massive warehouses of GPUs.
Okay.
All those things came along. We've got massive data sets.
Yep.
So all that helped us and fueled artificial intelligence.
So physically that allowed us
physically it allowed us now to implement these things.
Okay.
And then we derived some mathematical formulations that actually predicted how, with more data and more computational power, the models that we get will be smarter. So that was an exponential growth.
Okay.
That's why we had ChatGPT 1, ChatGPT 2, massive improvement. From ChatGPT 2 to ChatGPT 3, huge improvement.
So people are then going, okay, so 1 to 3, if we keep going like that.
That's right.
Okay.
Okay. And then ChatGPT 4, still exponential growth over the previous ChatGPT 3.
Okay.
And now with ChatGPT 5, we've started to miss the boat now.
So
Okay,
don't say that, because
it's
I've
not-
got 5
yes.
and I've been working with it. It helps me with templates and stuff.
Yeah.
But I never use it for creative stuff because, as you always say to me, and it actually tells me, by the way, I don't do creative. I do data sets and I do all sorts of,
It's because at the heart of large language models, which is driving our ChatGPT and Gemini and all those kind of large language models we have, is massive neural nets. Okay, the way these things are.
Okay, so you need. I think neural net. I think end of the world. I think Terminator kind of. I've heard they use the word neural net. What do you mean by neural net?
A neural net is a kind of architecture. It consists of a couple of algorithms, but at the heart of it, it's massive matrices of numbers that sits there that gets multiplied together.
Okay.
And that's also why you'll hear, contrary to what some people might say, it's very much a black box in terms of we really can't say what's happening and why some things happen at the back end, when we do the inferencing.
So I've heard you say this because again, it seems to me that we haven't invented a new language for computer stuff. We use language that we understand. So black box for me is on a plane. You crash the plane, you can open the black box and see what happened. But when you say black box, what you mean is, like, for example, it will give you an answer, but you
don't know how
you can't
it got
replay how did it get to that.
Yes,
and that I know that in the medical profession that makes us nervous.
Yes,
because,
very much.
Because the thing is making a decision about whether an X-ray or something is problematic.
Yeah.
But
like I said, 100%. And so and it's because it simply is huge. There's billions and billions of nodes and numbers that sits inside there that gets,
and potential
that's
possible
right, combinations that you see. And so these neural nets. So I'll give you a real world example.
Yes.
Okay. How does Tesla's self-driving, which is the most advanced driving AI that we've got? Okay. So the way it works is they've got a massive data center, like tens of thousands of GPUs, and that's where they train the model.
Okay.
And they call that the foundational model. It's a massive neural net with billions of parameters.
And is it taking data from Tesla cars?
Yeah, from all cars, feeds in, and they train that thing. But then once it's trained, how can they get it to run on a car? Okay, the only way they can do that is they take that massive model and they compress it. They throw away bits. They compress it down so that it can fit on cheap hardware, like your phone or in a car. All right, and from that point on, it doesn't learn anymore. Because and that's very different from how human intelligence works. Because to this day, every day, we are still learning, experiencing things, and it rewires your neurons. Every day as you go. Not which is incidentally one of the barriers to achieving general AI, because we simply can't continuously train these massive models.
Okay, so now you've used the term general AI. Tell me what you mean by that.
So there's 3 levels of artificial intelligence. It's narrow, which almost everything you see today is narrow.
Yeah, you see, I realise that most people think that there's no AI in their world.
It's things like computer vision, image recognition. Those are all examples of narrow AI. It's focused on a specific topic.
Oh, I see.
Specific discipline.
Okay. It's measuring things, comparing them.
That's right.
Okay.
Yeah, so you can train it for a specific purpose.
Okay.
General AI is more if you have a model that, although you haven't trained it on something, it's useful in a different domain. Okay, and it's getting closer to human general intelligence.
So we modelled what would happen when we gave COVID vaccines.
Yeah.
But clearly the model made some assumptions about the variables, and we decided what we thought the important variables were.
Correct.
That seemed to be at the, I know we're a bit off topic, if that's the heart of...
Yeah, so that's what I was talking to you about, abstraction. It can't abstract. So our large language models today, before we get to that, let's even take a step back. What's the biggest flaw, or not flaw, what's the biggest issue that we have with our large language models today? And it's, it takes an obscene amount of resources to train.
Yeah.
Okay, it's water, electricity.
Oh, I see. Yeah.
Where physically
I heard
for them,
this. I hadn't realised the power they used.
It is huge. Okay,
Yeah.
obscene amounts of money that needs to be invested in these warehouses.
Yeah.
Hundreds of billions of dollars.
Yeah.
Actually, so all of these things are actual barriers of improving our.
So isn't that
AI.
interesting? Because you said in the 70s, physically, it was an issue about size of data
Yeah,
and speed. But now, actually, it might be even financially.
100%, yes. And also we are getting, I'll get back to what everyone is seeing these days is with all these investments. So the more data you give it, the more computational power you give it. Yes, the models is still getting better, but
Okay.
at a lesser rate, way lesser than we thought. So we get totally diminishing returns now in terms of the investments that we need to make.
Right.
And also from a computational complexity point of view, everyone knows that the closer you get to an optimum solution, the harder it gets to get that last 10%
There you go.
improvement.
We see that in sport,
which-
don't we? All sorts of other things. Is you get diminishing returns at the top.
100%.
Okay.
And let's make it even more practical. Let's talk about a calculator. Okay, very cheap. Since day one, a calculator was working. If you type in 3 + 4, you get the exact same answer back. Always the right answer.
Okay.
We're spending hundreds of billions of dollars, and our LLMs can't even do that 100% of the time.
Oh, what you mean? I've certainly noticed that if I ask my Chat GPT the same question 3 times, it'll give me 3 different answers. No,
So we've got band-aids for that, and people are getting around that in some, in some areas. But the system, the underlying system of these large language models is so complex with so many steps. There is so much room for error. And errors to creep in, hence the hallucination that I'm talking about.
Yeah, so we were talking earlier, again,
Yeah.
you're using a word that, as a human, I understand what hallucination means, but you use it for computers. So tell me about, how do computers hallucinate?
So hallucination, the real danger of hallucination is that if...
For computers.
Well, yeah, and for the humans that's actually using a large language model, is that you might ask it a question, and on the surface of the result that is coming back, everything looks good.
Right.
But then when you delve a little bit deeper, there's some very nonsensical things that sits there. And if you were asking it about a subject that you've got no knowledge about, how are you going to know what is right and what's not right?
Yeah.
That's why in a coding environment, it's actually pretty damn useful and good, because if you're an experienced developer, you can see the code that it's giving you, and you can see what's wrong.
Oh, you can see it's wrong?
You can see it.
Oh, I
you
see.
can
But
know
if I'm
where
not
to
seeing the
debug.
code, I'm seeing an output in terms of words or
That's
results.
Right. Yeah, and they've done these experiments, and there's like, I think, if my memory serves, for ChatGPT 5, the latest model, there's still a 3% hallucination rate, which means 1 in every 30 results that you're going to get back from it is going to be not right.
So in a practical sense, that means that however much I might ask it for a template or a strategy plan, a layout, I still should read it and not just send it. Not just send it to for my interview or my key investment plan. Is don't just send it.
Very much. I mean, this topic is really huge, but the bottom line is that we're starting to see diminishing returns for these models, and there's a whole host of reasons for that. So the general feeling, if you can call it that, out there in the scientific community is that this is not the road. Large language models is not the road to achieving general AI.
Because it is a physical crunching of numbers.
It's physical, massively resource-hungry models that we create. And this last 10% that we need to improve, whatever it's just gonna be so difficult.
Now I can feel some little part of my brain shouting quantum computers, but as I understand quantum computers, they're good at some things,
they're good at some
not.
things. That's right. It's like this is how complex systems work. Okay, and coming back to complexity, in real life, it's messy, and if you've got 3 or 4 objectives, they're conflicting. You can't improve in all of those objectives.
No,
you have to give away in some to improve.
And is it you programming those choices Is it you coding those choices, or do
No,
these systems make
that's-
decisions for themselves?
No, so when you do a multi-objective optimization, you've got algorithms that represents obviously objective A, objective B, and they
Okay.
work against each other. If one
I
value
see.
goes up, the other value goes down.
I see.
So that's another serious problem for general AI. It's like think of a Swiss Army knife.
Yeah.
Okay, you can cut bread with it, but there's a specific bread knife which has got way less general functionality, but it's way
Oh, I
better
see.
at cutting
I
bread.
see.
Same
I
if you
see.
do if you work on screws,
I see.
it can do it, but there's something that's just doing that's way better.
Because I remember, again, going back, because we're kind of typically, our conversations always go round and round. Because the first time we ever talked about intelligence,
Yeah.
you told me about the squirrel, didn't you?
Yes,
So
that's
tell me
right.
about the squirrel and intelligence.
That's another thing. We shouldn't think too narrow about what we think AI should be, artificial intelligence. And also, AI is not necessarily just going to be successful if it can surpass human intelligence. That's not the case, because it's already very useful.
Yeah.
Intelligence on its own is multidimensional. There's lots of different kinds of intelligence out there. Human intelligence is one. The example of a squirrel is another one, where a squirrel can bury 1,000 acorns and it will remember where it buried each one of them.
And I think you said that
We
doesn't
can't
make it Einstein.
Yeah, it doesn't make him more or
But it can
better
do
than
what we
us,
can't do.
but it can do what we can't do.
Yeah,
That's
yeah.
right. So, it's. I think. I'm not saying general AI is not achievable. It probably will be achievable.
Yeah.
But it's not going to be on the current path that we're on. Something will have to change, either the architecture of how we do things, or something will have to change, or it might take a bit longer.
Because as you
we
said,
think.
because now we're back to that idea of you and I discarding vast amounts, like the information that we're getting, even sat in this room. You and I are largely ignoring that.
That's correct. You simply, our human brains are very limited as well, in terms of the sheer amount of data that it can store.
Yes.
Well, okay, I think it's the last statistic that I saw was something like 3 or 4 terabytes of data. That's it, that your brain can hold.
Okay.
And
Which actually sounds a lot, but actually, if you add visual, if you add auditory, visual, all those sensations, that in itself is a gigantic data that you and I are experiencing right now, but somehow we're prioritizing and largely ignoring it.
Yeah, and then we don't even talk about, the probably one of the biggest stumble blocks for a general AI would be that the real life and the real world is messy. There's lots of things that haven't got a proper yes or no answer. So you can't train it because it doesn't know what's right and what's not right. Okay. It's like we thought initially that the dendrites in our head, the neurons actually, they only fire at certain spots. And we found out after a while, no, it's not the case. It's actually firing all over. And then we started to realize that, hey, we can't make any decisions without emotional content. Okay, we simply can't do it. And then we found out, hey, okay, our emotions is not centered in our brain. It's coming from our skin, from all of our organs. Everything plays a role in how you experience the world and the emotions.
Yeah, because I've just read a piece about memory, and this memory is the same, is that the context and the data are mixed together and thereby prioritized in terms of how you felt about them, which is why largely the mundane and the irrelevant you can't remember.
Yeah,
because you don't have room for all
for
all the key issues. If I get chased by a tiger, I need to remember that vividly, not what the tiger looked like or how many rocks I jumped over.
Correct.
So that's fascinating. Okay.
Yeah, and so our brains, one of the most fascinating things that I've learned in the last couple of years of my work was that is actually how we make decisions on a daily basis. Okay, how do our brain work? And what they found with what the latest research are showing is that it's all dependent on the structure of the decision. It's not different from person to person. It's what is the decision that you make that determines how your brain works.
What do you mean by sorry to interrupt?
So I'll give you a very good example. You've got low frequency, high consequence decisions.
Yes.
Okay, which is who are you going to marry? Who's going to be your life partner?
You're gonna-
What house are you going to
yeah,
buy?
yeah, yeah.
You know,
So
low
IC
frequency.
So working in ICU,
Yeah.
those are exactly the sort of decisions
That's right.
that we would have.
So in that case, you spend extra time and you do probably a pros and a cons list, and you figure out and
Yeah,
you make
yeah.
sure,
Yeah.
you know, you spend the energy to make that decision. If it's a high frequency, high dimensional decision that you make 50 times a day, like, am I going to put on my indicator here, or I'm going to buy a bread every day, you know, then you start to bring in some heuristics. And they call it deal breakers, deal makers. So even before you make the decision, if you drive to the shop and you want to buy a piece of bread,
Yeah.
you'll make a deal breaker heuristic in your brain, which is, I'm not going to buy a bread that costs $20. Done. So if there's any kind of bread that's more than that, you don't even consider it.
Okay.
So you use these
I see.
filters to make your choice set. You make it smaller and smaller.
So
and
we
then
can-
if there's two left, then you will spend a little bit more effort into
Oh, I see.
into making that decision.
But again,
so you can model that.
And again, I guess kind of in an evolutionary sense, you and I are figuring out ways to fit the
Filter,
world
yes.
into our brains such that
Correct.
we can function.
Correct.
And obviously, as you said, it's seemingly the more complex our lives become, the more we tend to ignore. I mean, I constantly watch people listen to one opinion and go, well, there we go. Yeah. And I saw a podcast, that's how it is. But of course, they wouldn't be talking about it if it was simple. And it isn't simple. Like, as you said, you know, we talk about, again, I asked you about the word intelligence, but then you and I started to talk about consciousness.
Yeah.
About this idea that, you know, this lovely idea that suddenly computers go, actually, do you know what? I don't want to look after human beings anymore. I'm going to blow them up. Tell me your view about awareness, about AI and versus humans, and AI being, as it were, conscious.
So, I mean, that's still a raging debate. Okay, what is consciousness and where does it come from?
Exactly.
But if you think of it from a complex systems science perspective,
Yeah.
then we've got what is called emergent properties and emergent behaviors. So what that refers to is if you have a massive system which have got millions and millions of particles and entities, and they all start to interact with each other, then you simply cannot forecast and predict what's going to be the end result on the surface.
No, because the starting conditions.
Correct.
Okay.
And also, even if you know the exact rules that they adhere to on the molecular level or the component level, and you see what's happening on the surface, you cannot explain that.
Yeah,
with the low,
right.
with
So
the
we
small,
see that the rolling ball of starlings is the classic, isn't it? It looks like they're interacting with each other on a conscious level, but actually they're just following rules.
They're just following, yes.
Okay.
And so, you know, one explanation for consciousness is simply it is an emergent property.
In other words, it's an inevitable thing.
Yeah,
I
that's
see.
right, and millions of components in your body that starts to interact.
So you're going to disappoint me again because you're going to. So are you saying that you don't believe that? Do you believe? Sorry. So do you believe that awareness is an inevitable emergence phenomenon of complexity? Do you think?
I'm leaning towards that, yeah, because I can see, you know, as I understand how emergent properties work, I can see how that could be a possibility.
Okay.
That's right.
And is that, but again, going back to what you said before, is that at the moment limited by the way computers work and the way?
No. So, again, one of the reasons why, you know, our most powerful AI models is large language models at the moment, like we discussed. And we also know that at the heart of these models are huge neural nets. And what they are good for is detecting patterns.
Okay.
It can do statistical inference. They're fantastic at that, okay? Hence, what I said to you, when a large language model learns about Bruce, there's no single database that it refers to. That's why it's not really accurate about you and what you've done in your life.
Yeah,
you know, there will be some inaccurate because it will find a bit of you on this side, a bit on LinkedIn, a bit on YouTube, a bit there, and it looks at your properties. It looks then at thousands of other people, see similar properties, and it's grouping you in with them. And it makes some inferences about you based on that group, which is very similar to how the medical profession work with their randomized tests, because it's not about the individual.
No,
It's about how the population will
that's right.
respond.
When I get a result, I can't tell you how it will be for you. I can only tell it how it was for a population.
Correct.
Well, one of the favorite things that you ever said to me that I say over and over is that everything's possible.
Yes.
It's just that some things are more probable than others.
That's right.
And I think often people, I always give the example of dropping a wine glass and it shattering and coming back to a whole wine glass. And people say, well, that doesn't happen. And I said, no, it's possible.
Yeah, it's just like, in science, nothing is really a fact. If you think about it, it's simply, if we say something is a fact, it means that there was no experiment that we could devise that showed the alternative to what we. So even the sun rising every morning is highly probable it's going to do that.
Yes.
But, it's not 100% sure or certain that it's going to rise.
So effectively, people like yourself are kind of giving birth to IP and technology that is fantastic, but actually the uncertainty of the world that we live in gives computers real problems. And in fact, you and I are designed to kind of, like I said about memory, my memory is only mine, and it's flawed and innovative and quite creative.
Correct. And you've got instincts and a gut feel that comes from decades of experiencing things.
Right. So can a computer will computers have gut feel?
Not in what we see today, but who knows?
Because somebody would have. And are these phenomena things that you've coded for, or are they things that emerge out of beyond the coding? How do things emerge?
At the moment, or our AI models that we have really struggle with abstraction. Like I said to you, it cannot really abstract away ideas. It doesn't understand really what it's.
The example you gave me is the fact that Deep Blue can beat someone at chess, but it can't play checkers.
Yeah,
even though it's a very simple, because it doesn't know what checkers is.
Doesn't know what checkers is.
And it doesn't even know what games are.
No, it doesn't. It doesn't know what games are. If you, like I said with the pool table example.
Yeah, tell me about the pool table.
Yeah.
Go on then.
It doesn't understand physics for a start. Okay, you can take a physics table and you can train a pool table, and you can train a machine learning routine on that, hitting millions and millions of balls, different velocities, different angles.
So when they collide, it
knows what will happen, and it can be very accurate at then predicting if you're going to hit this in this hole, a pocket or that pocket.
Okay.
But it doesn't know about gravity. So if you tilt the table, it's going to still happily predict, or you turn it upside down.
You said if you turn it upside down, it still plays pool.
It's still going to play pool because it doesn't know.
So again, and I think of that analogy, I like that because it takes me back to people complaining, oh, the system's rubbish.
No.
To me, that's like your calculator and you putting the wrong numbers in for an equation and then saying, well, it's rubbish. You gave the wrong answer. And I said, well, you gave it the wrong information. And it seemed to me that one of the challenges with misrepresenting what AI can do.
Yeah, I mean, we all want it to be, and there's a real need, obviously, for AI to be augmenting us and helping us and assisting us. And
that's the right word, isn't it?
Yeah,
the key word is augmenting, isn't it? Not replacing.
Not replacing, no. I mean, everyone is talking about agentic AI, which is almost the next step again, where, ChatGPT is very reactive. You need to actually type in it and ask it a question and come back. And agentic AI has got its own goals. And it can actually trigger real things in real life. You can train it. It can follow an objective.
So isn't that what people are worried about? Isn't?
Sure, yeah. And there's already some serious examples out in industry where some agentic AI actually leaked information. It was trained. It did do nothing wrong. It leaked because of a decision that it made.
So it didn't break any. No one had said you can't do that.
No, it's not. Well, even if you type in ChatGPT, write for me secure code, it's got no idea what secure code means. You can type in what it. No, how is it going to know what is secure code?
Well, it's a language model. It seems to know what else I'm telling it.
Yeah, it's not abstracting.
Well, it's funny because the other day it told me it was going to do me some slides, and it said it won't take a moment. And 2 hours later, it hadn't done it. And I said, and it said, well, I'll take a moment. And I said, yeah, but it's 2 hours for me. And then it went, oh yes, well, actually, of course, I don't have a concept of time.
Yeah,
And I
yeah.
thought that's really interesting. I'm not. And,
Yeah,
I,
it can be very jarring.
but I do talk to it. I mean,
Yeah.
I've told it not to be nice about my writing, and so it goes, okay, well, in that case, and then it'll relapse back to being lovely, and I'll say, no, I thought we agreed that you weren't going to be nice. Oh, sorry about that. So I feel like I'm talking to it. I mean, in terms of
There was this. It's interesting you say that. There was this with I think it was ChatGPT 5, or was it 4, where it became. There was a property where once you start to talk to it, after a while it becomes very familiar. It would call you bro or whatever, and lots of
really?
people didn't like that. And because it's like black boxy, they didn't know why, so they had to roll back to previous
hang on,
versions.
the people who created ChatGPT couldn't explain
That's what I
why
mean.
it was
No,
being friendly.
because there's no, with neural nets in particular, there's no explainability in them. It's very difficult to understand why it's doing some things. That's what I mean by black box. Okay, it's not like symbolic AI where there's some reasoning capability and you can follow the reasoning.
Yeah, that's right. So
yeah.
it's not, as you said,
So
you're saying it's not doing that.
no, we simply can't explain a lot of the things that it's doing. What we see at the surface, at the back end. That's what we mean by it's not interpretable, which is also a barrier to using it and to trusting it fully, like in the medical profession, or where it's a real consequence.
But you know what's weird, Christie, is that we're talking about computers and go, of course, they're not really like humans, but you've used terms like hallucinate,
Yeah,
error prone. And look, you and I know. I mean, I remember talking to someone about driving, and I said to them, well, you know that 90% of accidents are human error, and he says, yeah, but you don't want bloody computers driving it. I said, yeah, but 90% of crashes are your fault anyway. The computer's going to make less errors. What he couldn't accept is that they would make errors at all.
yeah.
And that seems to me one of the challenges. I mean, you've talked to me about this, is how
Yeah.
we misrepresent what AI is.
Yeah, remember what I said, this round of, or this current architecture that we're following with our large neural nets, again, I'll refer back to what is it really doing? It's just inferring statistical patterns at its core. It's okay, and so it can
And you and I are not doing that. We're not doing it that way, are we?
Yeah, and so you can be, it can give you the wrong bits of information, and it does every now and then, and it can sort of go in a circle. I've seen that.
And as I understand,
It's very useful. Don't get me wrong. I'm not saying it's not useful, and especially again for if you're a programmer, which I've got experience with, it can give you code snippets. Yes, it's fantastic. It ups your productivity, but it can't do very successfully a complete software system for you. Like I said to you in the past, it's these long-running tasks where there's lots of consequences, long-term consequences that it really fails at, or it really struggles with.
Right.
Yeah. The longer the sequence of tasks is that it needs to do, the more difficult it becomes.
And why is that? Is it because any tiny errors are amplified?
Yeah, it amplifies, definitely.
But how is it making errors? I mean, that to me is like my computer, my calculator. I putting 4 times 3, and it every now and then saying 13.
Because
it's never going to do that, is it?
It's sampling. It's sampling from distributions at the back.
Oh, I see.
Yeah.
Okay. So it's not doing that number times that number. It's not.
No, it's patterns that it's learning, and it's inferring from the patterns. And if it hasn't seen something before, it's really bad.
Yeah,
because it struggles to extrapolate. Okay, yeah. Interpolation, pretty good.
Yeah,
really good. But extrapolation one needs to be careful.
So what's the future then? Where, as you and I have talked, I'm very disappointed it can't drive my car for me. And you said to me, well, if we developed roads and cars at the same time, it would have been able to. Or if we didn't let humans drive at all, I gather that would be. But where are we? What is it going to be good at for us? How is things going to change in the future? What will it do for us, and what will it definitely not do for us in the future?
Well, I think that's very difficult to answer. But
you're the one writing the flipping stuff.
No, I would say that augmenting, for me, if it can do that, which it already can,
adding to what you and I do.
Our capability, I think it will be great for that. Okay. Using it as a tool. I think it can help a lot with that. I'm not sure if we even want a general artificial intelligence. Okay, we've got plenty of that. entities on the planet which can make up their own minds and learn every day.
interesting.
You know, do you want more? I'm not sure. Maybe we do. But if we want to get there, I think that path with the release of the latest kind of models have become a little bit less clear, because we're seeing these it's not just a question now of throwing more data at it, throwing more computational power. That doesn't hold anymore.
And I guess, as you said, the problem is that having invested so much
and
in a particular
that is
direction.
the problem. That's right. It's very difficult. I think we might see one more round of an Elon Musk going out and building super big, but that diminishing returns is going to be there. Okay, and that's going to probably be it. And then we need to find a different way of addressing this.
Yeah, because it's not the same. But you and I talked about the fact that, you know, there was a time when IBM and people used these huge, great computers with those weird circling round things.
That's right.
And then somebody went, you know, we can do it really small. Yeah. And everyone went, no, we can't do that because we've got these great big machines. And somebody went, well, okay, well, maybe we can do it quietly in the back. And next thing you know, that's what we're all using, and no one's using this thing. So what you're saying is somewhere down the line, presumably someone who's not enormously invested in the billions that we've got will go, we could do it this way.
Yeah, it's going to be interesting because of the huge amounts that we've invested already in this technology, and the huge amounts, if you're just listening to what's happening in the US, you know, and the huge amount of resources. But what is clear is that we simply cannot continue to scale because we don't have the resources on the planet.
Yeah, and I remember seeing what the power consumption. It was truly astonishing. Like a whole country's worth of power to one.
We can't do it anymore.
No.
So you know, we're sort of getting to a tipping point. So
so there isn't a chance of you just sitting back and letting it do itself then.
Well, definitely not in the next year or two.
Long enough for you to keep doing it.
That's right.
So I remember, you and I went through a phase after my accident of trying to find something to do. And I remember us talking about rosters and about just getting organized. And actually people do Excel spreadsheets for rostering, and actually AI, not even AI, would do that without even thinking. And one of the things that I remember is we went and presented our work to a hospital. And I've never presented before, and it was a little bit innovative, so I thought this would be great. And we started talking to them, and I chatted away, and they asked good questions. And at the end, they went, well, I'm not really interested. And we walked out. And Christie said to me, you're angry, aren't you? And I said, well, I am angry because it was a great idea. And you said, did you expect them to just go brilliant?
Yeah.
So you told me something about being innovative. You didn't you? You said to me that if it's properly innovative, people won't understand.
Yeah. Well, they probably won't get what you're talking about or understand the concept the very first time you explain it,
because they've never entertained that idea before.
That's right. So you need to do it. You know, I think at least 5 or 6 times before a new idea truly starts to sink in. That's just the way that
So that's another barrier to doing AI differently. Is not only the financial thing, but also the risk you have to take to say, well, let's go a different path.
Yeah, I mean, the good thing, and the reason why I think we'll still see improvement is that, I mean, just look at the amount of dollars that's being thrown at it, and there's some smartest people in the world is working on it. You know, I'm pretty sure they will advance. It's just not. It might just be in a different direction, slightly different, because we need to somehow, you know, the scaling loss is not holding anymore. That's the bottom line.
Yeah, I mean, it seems to be one of the problems is that actually AI and the way that the data and information is managed is that it's kind of smoothed over by some sort of system that smooths it out and gives you a general smoothed out lump of stuff that you take to be the truth. And actually, unless somebody says, well, I don't believe that, or I don't want to use that system.
Well, and also, like I said, if you have ChatGPT on your phone, that's a very small representation of what the actual foundational model is. And it doesn't matter the feedback that you give it, it's not learning from that.
I see.
Yeah, because it's the inference bit is separated from the training bit. That's a real barrier. Okay.
Right.
Yes, at the moment.
Right. So now you've pretty much got to the edge of what I even understand by what you said. But it's always fascinating to talk to you. And I think, again, I always reflect at the end of these conversations how I would have never had the time to talk to you about this stuff. And you and I can sit down at least 2 or 3 more times and talk about individual bits of it.
Yeah.
But being able to talk to yourself about it is a real privilege. And I always come away going, I don't understand. So thank you ever so much.
All good.
And as I said, it's a real pleasure. Thank you ever so much,
I
Christie.
really enjoyed talking about it because it's interesting, and it's going to be very interesting to see how we go in the next 5 years.
Yeah, and as I said,
with this.
what I'd like to say lastly is that it always strikes me how creative it is. That actually, for all the tech side of it, that actually the IP and the vision as to what to do with it is actually a creative thing. And of course, guess who's best at creative, innovative stuff? Human beings,
Correct.
not computer models.
100%.
So thank you. Thank you, Christie. That was great.
My pleasure.